When the sun goes down and the wind dies down, what to do with the surplus of renewable energy generated during the day? It's a question that has plagued scientists for decades. One of the most promising solutions is to harness the Earth's gravity and store energy in gravity batteries. These giant devices can store electricity for hours. Gravity energy batteries use the force of gravity to store electricity. They work like giant scales. By lifting heavy loads up, they store potential energy and then use it when lowering the loads back down. But could such technology become a ubiquitous reality? How much energy can gravity batteries actually give off, and how long do they last? Let's delve into the design of these giant storage units and their potential for green energy in our review today. Gravity is a powerful force, and now scientists have learned how to harness it for the benefit of mankind. The idea of storing energy using gravity has been known since ancient times. For example, in China in 200 BC, water wheels were used to pump water to a height and then use it to spin millstones. The first device in which gravity provided the energy for mechanical motion was a conventional pendulum clock invented by Huygens in 1656. They worked by gravity, causing the pendulum to move. In the 20th century, interest in gravity accumulators increased due to the development of renewable energy sources. Sources such as solar and wind power were unstable and could not always provide an uninterrupted supply of energy. In 1906, the first pumped storage system was built in Switzerland, which according to the general principle refers to gravity batteries. This system used energy from renewable sources, such as hydroelectricity, to pump water from a lower reservoir to an upper reservoir. At peak times, gravity forced the water to flow back into the lower reservoir, driving turbines and generating electricity in the process. Today, such systems also utilize energy from renewable sources. For more than a century, the pumped hydroelectric energy storage method has been widespread and is the most popular method of storing electricity in the world. However, scientists are now proposing to do away with water and utilize the pure gravitational force of the Earth. Such gravity batteries could be a solution to the problem of storing solar and wind energy. Let's find out how they are organized and whether they can change the world. The idea is simple. Gravity batteries work based on the principle of converting potential energy into electrical energy. When the battery is charged, the load rises to a height, using energy from an external power source to lift the heavy load from the bottom to the top. When discharged, the load falls downward due to gravitational force, actuating a generator that produces electricity for the consumer. It must be understood that the load does not fall instantly. It is designed in such a way that it descends slowly. That is, the system is able to give energy for several hours. In fact, everything depends on the weight of the load and the height of the lift. At the same time, it takes only a few seconds to switch from charging to discharging mode. That is, the system is able to respond quickly to peak loads. This is the method that was used in 2022. The first commercial gravity battery was launched in China. The total construction cost was about $200 million. The system was built by Energy Vault and consists of two 100-meter-high towers housing 100,000 concrete blocks, each of which moves a 30-ton load. The system has a capacity of 80 megawatts of peak power. When the battery is charged, the blocks are lifted upwards by electric motors, and when discharged they fall downwards, driving generators. This battery has a capacity of 25 megawatts and a storage capacity of 100 megawatt hours. It can power about 10,000 homes for 1 hour. The gravity battery operates at temperatures ranging from -20 to +40 degrees Celsius. Energy Vault is currently planning to build 5 more such batteries in China. They will be built in different regions of the country, including Shenzhen, Changchun, and Xi'an. The construction of the new batteries will contribute to the development of renewable energy in China. They will ensure uninterrupted power supply, reduce dependence on fossil fuels, and reduce greenhouse gas emissions. Gravitricity batteries are also planned to be built in other countries including USA. Gravitricity plans to build 50 megawatts of gravity batteries in California and Texas. UK. Gravitricity plans to build 50 megawatts of gravity batteries in Scotland. Switzerland. Energy Vault plans to build 50 megawatts of gravity batteries in Switzerland. Germany, Japan, and South Korea are also conducting research on gravity batteries. What makes gravity batteries better than their lithium counterparts? Let's compare these technologies. First of all, gravity batteries are much cheaper to operate. It costs about 4 times less to store 1 megawatt hour. This claim is based on a study conducted by Energy Vault in 2022. The study found that it costs about $200 million to build a 25-megawatt hydroelectric power plant and about $800 million to build a lithium-ion battery of similar capacity. Secondly, they last much longer, up to 80 years, without much maintenance. Lithium batteries have to be replaced after 10 to 15 years. Thirdly, lithium mining involves harsh working conditions, human rights violations, and depletion of reserves. And for gravity batteries, it is enough to use improvised materials like concrete. We should not forget about the fire hazard of lithium batteries. Gravity batteries are absolutely safe in this respect, and a gravity battery can be hidden in a mine. In addition, gravity batteries take up less space than other types of batteries. For example, storing 100 megawatt-hours of energy would require only one mine, whereas storing the same amount of energy would require several square kilometers of space to accommodate lithium batteries. For example, unlike hydroelectric power plants, they do not need a specific landscape. A gravity battery can be placed anywhere, even hidden in a mine or on a plane. The main thing is to use the Earth's gravitational force to store energy. So for Europe, with its coal mines, gravity batteries are a godsend, an environmentally friendly solution to the problem of energy storage. But don't forget that there are several different types of gravity batteries, which differ in the method used to store energy. There are several varieties of these useful devices. The most common types of these accumulators are water pump systems. The cost of building such a system is about $1,000 per kilowatt of power. They work like river hydroelectric power plants, only in reverse. Using electricity, water is pumped to an upper reservoir and then released to a lower reservoir, spinning turbines. Water pump systems can range in capacity from a few megawatts to several gigawatts. The capacity of such systems can reach several gigawatt hours. Their efficiency is about 80%. This is a time-proven technology that allows the storage of huge amounts of energy. The second type is towers with movable loads. Imagine a skyscraper with an elevator where concrete blocks go up and down instead of people. This method requires no water, but takes up more space. Towers with lifted weights can range in capacity from a few megawatts to several tens of megawatts. The capacity of such systems can reach several hundred megawatt hours. Their efficiency is about 70%. The third type is mechanisms with weights that use hydraulics or mechanics for lifting rather than electricity. Their energy conversion efficiency is about 60%. They have the same pros and cons as the second option. Systems can be co-located with renewable energy sources or built standalone. Gravity-based energy storage systems are designed to power our lives and create a world based on renewable energy. Gravity batteries have great potential to solve renewable energy problems. They can help provide an uninterrupted energy supply, reduce dependence on fossil fuels, and reduce greenhouse gas emissions. However, gravity batteries also have some disadvantages such as high construction cost and space requirements. In order to further develop this type of batteries, it is necessary to reduce their cost and improve their efficiency. But nowadays there is an active research of gravity batteries in different countries of the world. The main directions of research are aimed at reducing the cost and increasing the efficiency of gravity batteries. One of the ways to reduce the cost of gravity batteries is to use cheaper materials. For example, some projects use cheaper materials such as metal or plastic instead of concrete to make the blocks. Another way to reduce the cost of gravity batteries is to optimize the design of the batteries. For example, some projects use more compact mechanisms for lifting and lowering loads. To improve the efficiency of gravity batteries, research is being conducted into the use of more efficient materials and technologies. For example, new methods of generating electricity when loads are lowered are being developed.